Hello and welcome to a special session of Digital Futures on AI and Education. This is something that we've been talking about for some time. It's already something that we've been debating in many ways. We've devoted 2 sessions to education, and we devoted many sessions to AI. I'm delighted to have a distinguished lineup of some, I think, very representative figures within the field. Here with me today, we have Areti Markopoulou, the director of IAC, which has always been a very progressive school in many ways, but it is both producing online programs now and also launching, I think, maybe the first master's course on AI and architecture devoted exclusively to that in the autumn. We have also Behnaz Farahi, who is no stranger to many of you either. Behnaz is an interesting situation because she's currently teaching in a school of design and teaching many people about AI who don't have a design background. Behnaz, as you probably know, is quite a distinguished designer and also the editor of 2 books, one on interactive design and one on 3D printed body architecture. We have Ila Colombo, who is part of Dion with Ross Lovegrove in Dubai, and part of, I think, what is a very, very forward-looking and progressive city that is embracing AI in an extraordinary way. We have Joseph Choma, the new director of Florida Atlantic University, that has already established itself as a leader in the field of AI. Not only do they have Daniel Bolajan there, along with Shemaine Youssef and Manas Famiso, but they've actually now launched a PhD program run by Daniel Bolajan, looking at AI and creativity. Finally, we have Philippe Morel, again, no stranger to any of you. He's directing the program on computational design at the Bartlett. He is himself quite a renowned designer and figure and academic. He's just wrapping up his doctoral design program at FIU, which is an online program that maybe I might mention briefly. So today it's a chance to really think about the context of what AI means, or rather think about AI in the context of the classroom. And here, this slide deliberately, actually, whenever I type in AI, I get robots. Of course, a robot is not AI, but somehow this is what Midjourney thinks it is. Robots might be controlled by AI, but they're no more AI than a Tesla car is AI. But we have a robot, and in the background, a chalkboard, a world of the classroom that really, frankly, has not changed substantially for hundreds of years. The basic model remains the same. And it seems to me very clearly that we are in a moment of change when we need to begin to open up to new ways of thinking. If there are two, so today we're going to be basically looking at the question about, and it's laid out here very clearly, in the age of AI, every profession has been disrupted. Architecture is no exception. What role will AI play in the future of architectural education or design education more broadly? And what role will education play in a future dominated by AI? It's a twofold kind of question. If there are if there are 2 disruptors in our world today, it seems to be very clear that one is COVID and one is AI. And indeed, Digital Futures itself, as in its contemporary mode of existence as an online program, a para-educational program that is not necessarily connected with any one institution, nor indeed with any one language, nor indeed with any one time zone. That model really came about because of COVID. Back in 2020, up until 2020, we've been holding in-person workshops, and it became obvious that that would not be possible with COVID. Initially, we abandoned all hope of actually doing anything that year. But then we realized that already we were seeing new modes of operation coming about, but with COVID. COVID was forcing us to, it was a disruptor, forcing us out of our comfort zone, forcing us to adopt new ways of approaching things that had already been there. We'd already had contactless payment. We'd already had Zoom. We already had the possibility of online education. But that had not really been pushed. We were forced into that situation. And what happened in the summer of 2020 as is kind of now history, is that all of a sudden Digital Futures burst onto the scene as an online platform with not just a few hundred followers, but many thousand followers. And as a result of that, we began to keep the platform open, not just for the summer event, but also throughout the year. And as a result of the success of that, we then started operating in many different languages, and indeed having a starting time changing according to which language channel we were operating with. So Digital Futures kind of was born by the necessity of engaging with this kind of world. And what we found, much to our surprise in some senses, that we were just simply trying to find a new way of operating, that actually it was an incredibly successful venue, that we are able to not only break through the walls of the classroom, but also get the message out there to break through the social, political, and economic boundaries that have previously prevented us from sharing ideas. So we began to realize that it had an incredibly important role in democratizing education. Education, we believe, shouldn't be a privilege of the wealthy, but should be a universal human right. And that's really what has been driving the whole agenda of the platform ever since then. The idea of sharing knowledge across the planet, and to have followers as we do every week from places like Bangladesh or Iraq or Kenya or whatever. We are broadcasting to the world, which probably explains why we start at the time we do, because that is the time, 10 o'clock a.m. EST, 10 o'clock in China, and so on, when we can reach the most people. So it's had a huge impact. And what's more, we've now been opening up in all sorts of different ways. We've put our work onto YouTube, and we're getting, in many cases, over 1 million views for some of our videos, and certainly over 200,000 for many of them. And that seems to me to be an important step forward. Now, one of the sessions we had during COVID was how we needed to rethink education. COVID was forcing us, was challenging us to overcome, to get to a different sort of, to adopt different practices. And we had 2 sessions on this. One particularly significant one with Sanjay Sama, who is the head of open learning at MIT and the author of this book, Grasp, The Science of Transforming How We Learn, where he came on and gave us a super interesting kind of provocative talk, where he was saying basically that most knowledge, in any case, is already out there on YouTube. And then Areti was part of that discussion, and we were talking about how we needed to change the notion of the professor from being the content provider, from the person who has access to all knowledge, to being a kind of curiosity stimulator who could help point the students towards what was available online. Also, Sanjay Sama was saying that basically that we have an attention span of about 20 minutes, and that seems to me also a modality in how we're operating. So the model maybe of the TED Talk has been what's informing Digital Futures. Our sessions are longer, a bit like the interviews of Lex Friedman, but hopefully stimulating. But what it's sort of pointing to is the possibility that we can operate as another form of knowledge, that we can use the platform to share our ideas all over the world. And part of that initiative has been a kind of a pilot, a prototype that we've been developing called the Doctoral Consortium. We were focusing particularly on doctoral research, because the real problem about doctoral research is you normally get small groups of individuals with an individual professor communicating in small classrooms. And it seems very obvious, especially in the world of AI, where there aren't so many people who know what's happening at the cutting edge, that you need to adopt a global platform in order to transmit that knowledge. So the idea of the Doctoral Consortium was to create a platform for everyone around the world, a kind of global brain, as it were, bringing on the experts in the field and sharing that knowledge for free everywhere that we could. Now, that seems to me an important kind of gesture that could itself be taken further to all forms of education, into undergraduate education, master's education as well. It seems to me that we fundamentally have to rethink education itself. And the possibility of going online is clearly something that has been important. At FIU, we have a Doctor of Design program where almost all our candidates are all over the world. This actually wasn't designed because of COVID. It actually came out in conjunction with COVID. It had already been planned. And you have this possibility whereby you literally have someone like Wan Yu He, who's in Shenzhen in China, or Philippe, who's with us today in either London or Paris or Athens, and Sumin Ham in SIAP and so on, Aya Riyad in NYU Abu Dhabi, and so on and so on, where everybody can come together and share a platform. So we have a kind of there are disruptors are out there that are forcing us to operate in a different sort of way, and especially in the domain of AI. This is a recent session we had on OpenAI and Sora. So the question ultimately is, well, how do we adapt to a world where we've already recognized the possibility of online learning? We've already recognized that, but how do we adapt to a discipline of AI that is changing so rapidly? It's changing so rapidly that anybody such as myself, who's published a book in the area, soon finds out that book is out of date almost as soon as it's published. A world that is radically changing and where we have to try and rethink the logic of the classroom. Now, as we all know, AI, ChatGPT has already caused a degree of, shall we say, disruption. It's been banned from classrooms and then unbanned again. It's something that is forcing us to rethink that sort of logic. But in particular, if you think about the context of AI, which is facilitating the world of design in an extraordinary new way, how is it going to disrupt the way that we operate? And how is it going to change the way in which we have to teach architecture education? Should it be an add-on? Should it be integrated into the class? And how do we operate when, frankly, ChatGPT is giving us potential essays and Midjourney is giving us potential projects? What is the role of the professor in this particular domain? And then what role does education play in a future that's dominated by AI? What makes education so important is that we're at the forefront. We are educating the students of today who will become the architects and designers of tomorrow. And it seems to me, from my experience, it's actually surprisingly education that has been the slowest to adapt. Many practices have been forced to adapt to this. Zaha Hadid Architects, Foster and Partners, Core People and so on, many very progressive practices are now embracing AI and going ahead with it. Education, I would say, on the whole, has been a little bit slower to adapt. And that, to my mind, is a crisis. So today we're bringing together this panel of experts to try and debate these kind of issues. How should we be approaching this? What role does education play? What role does AI play in education, and what role does education play in the future of AI? So what we're doing today, we're going to have a series of presentations. We're going to spread them out and have a little debate after each of them. And I want to start by inviting Areti Markopoulou to say something from IAC in Barcelona, where they're about to launch a program on AI and architecture, a master's program. Areti, it's great to see you. Welcome.
Thank you, Neil. Thank you for the introduction, for the invite, and it's great to be among these brilliant colleagues. We have had a lot of opportunities to interact, and it's always great to create spaces as the one that you're creating in order to discuss, reflect, brainstorm, and share knowledge. From my side, I'm the academic director of IAC, and I am going to share a new program that we are launching driven by AI, but more than anything, trying to understand how AI could actually create a real impact and also a positive impact on the built environment, which is the one that our discipline operates. But before doing that, just because I had a couple of thoughts for that talk, and I just wanted to very briefly go into 3 points that I believe they are very important, because AI will undoubtedly affect not only the way we teach, as Neil was saying, but more importantly, the processes of learning. And in design disciplines specifically, I think that AI contributes in an emerging paradigm, which is a paradigm of collective intelligence, a paradigm of co-creation, a collective intelligence paradigm that empowers the applications of co-creation, following generative processes of both the living and the machine. And if we understand that machining intelligence could be considered another species, following philosophers' views such as Rossi Braidotti or Donna Haraway, then we can even place that paradigm as a kind of, as a post-anthropocentric approach. And co-creation with machines or co-creating with other species and other forms of intelligence is a radically changed, is a radically, let's say, mind shift change that we need to do. And I think that this is really something that we need to keep in mind. It's also something that goes against a bit how the discipline of architecture used to operate in a kind of a very top-down, kind of selfish way of a designer having a wish, a design, and trying to materialize that. A second topic is the issue of bias. The issue of bias in vast data sets, which is another key point to deal with as we educate ourselves for a future that not only operates largely based on AI technologies, but also for a future in which we as users, citizens and designers use AI as a tool to shape that future. Because it's extremely naive to think that AI processes are fully automated. I have been working with data for years, and I know well that the data set one chooses to select from, to work with, or to overlap, to generate conclusions or diagnostics or assessments are a human decision or a cognitive decision, and therefore is susceptible to biases. And this is also something that we need to keep in mind within the process of education, but also within the processes of action as designers. And the third point that I want to highlight is that the current crisis at all levels, climate, society, or the economy, require not only new ideas that AI can contribute to, but also new business models, that they could shake the business as usual paradigms. And therefore, architects need to acquire skills that not only encompass creativity and ideation or multidisciplinarity, but also extend to implementation, entrepreneurship, and the creation of these new business models. And maybe with that, I will just share some slides on a new program that we are creating exactly following this idea or this objective to try to create educational platforms that teach architects or designers or engineers on the one hand how they can use the potential of AI in a conscious way, in a responsible way, in an ethical way, and at the same time, how this could become new ideas and new business models. So that is a new master's we're launching, the AI for architecture and the built environment. And of course, IAC, as Neil was saying, is a place that we're always trying to learn out of making, to explore new processes of teaching, making, ideating, a lot of prototyping with our hands, but also a lot of prototyping with data in different campuses that we have. And for the last years, supported by the European Commission, we have been developing new educational models that they do exactly this merge of academy research and the startup ecosystem. So these are some of the projects, the BUILD projects or the urban shift, where we were bringing together architects, biologists, engineers in the case of the BUILD project in order to generate new processes of learning, but also new startups, and the urban shift that is merging expertise of urban technologies, of architects and designers, but and of course the business aspect of it. And our learnings made us to understand, working on these projects, that it is necessary to create a much more consolidated program. This is the Master of AI for Architecture and the Built Environment. Of course, it operates in vertical themes, urban tech, smart construction, nature and ecosystems, because AI can affect at different scales, but also can affect in different challenges that we face today. And we have three horizontal objectives. try to understand that architecture and design could become not just less impactful, but more than anything regenerative. Try to see how we can use the power of AI in terms of diagnostics, prediction, assessment, analysis in order to create carbon neutrality in the built environment. And of course, this idea of collective intelligence or this idea of co-design processes, which is not just among or between the architect and the machine, but it's also between communities, architects, decision makers, urbanists, and different kind of stakeholders. These are some of the projects that we have been working previously, how we can use AI, for instance, to map our existing built environments that could be reused in a circular construction. So use AI for urban mining. Some of the collaborators in the project, in the master that we are launching, are also working with Rethinking on how we design and how AI could create architectural designs. So take architectural designs using only words and transform them from theory, let's say, to reality. And that, of course, shakes our discipline, because then who designs how they design becomes like very critical questions. Or even use AI in order to have, as I was saying, this analysis and prediction modeling, for instance, AI for environmental performance from Infrared Cities, and Angelos Chronis, who's the co-director of the Master in AI. The previous work is from Theodoros Galanos, that he's part of our academic and advising committee. And we can see that there are different ways, like even going into the small scale of creating a low-cost monitoring kit and use AI for citizen action, environmental monitoring, give those kits, monitoring kits into people that they can put in their houses, and then, crowd monitor, let's say crowd sense the environment in order to have data that otherwise it would have been impossible. So in a way, and that's just closing this intervention, I want to highlight that AI is a tool, but we need to be able to understand it as a tool. And we need to be able to get prepared that this tool would become our co-creator, as well as trying to understand that every time our responsibility gets much more, it's higher in relation to what kind of data sets we use, with whom we create these co-creation processes, and then last but not least, how we can assess our final, let's say, solutions, and of course, how we make them a reality. Just to finish by saying that the master is in collaboration with the EADA Business School, which is one of the most important business schools in Europe and in Barcelona. And this also helps us to bring into our educational process knowledge that could allow us to shake the business as usual approaches. I think with that, I will leave it so that either we can have a discussion now or after the interventions of the rest of my colleagues.
Well, let's maybe just have a few quick questions. I mean, first of all, Areti, it's great to see this master's program. I used to teach in IAC on a weekly basis, and now I'm hopefully coming there.
You are a guest faculty in that program, so
yeah, absolutely. I'm looking forward to
you're
it.
going to join us in November.
Absolutely. I mean, Barcelona is somewhere I don't need to be. I'm persuaded to come to visit. But just one thing, back in when you started out, one thing so interesting about IAC, the way that I thought about it, and I think I'm changing my view now, was that IAC was the result of the failure of most schools of architecture to address important questions like robotic fabrication and so on. And my view to begin with was that IAC would eventually cancel itself out as graduates from IAC were teaching all over the place, and everywhere else came up to speed with IAC. But it seems to me that actually what we're talking about is not one singular gesture, but rather a kind of continual program of renewal. Almost that IAC is the face, the face of change, the point of change, and itself continually evolving in order to address these new ideas, these collaborative startups you're talking about, and so on and so on. So it's almost like, I think there will always be a kind of role for the IACs of the world to really kind of push the boundaries. But in some ways, it does sort of, I think, model what we're trying to do in digital futures to try and step in and fill the gap and provide what's missing from the world out there. I want to invite maybe some other on the panel to maybe ask a couple of questions before we move on to Joseph Choma. Yes, any thoughts, anyone?
Maybe just to say as well that new educational models also require to rethink which is our educational campuses and spaces and how they are created. And I'm saying that because for years at IAC, we have been preparing ourselves for a new campus, and then it never happened for many reasons. But a year ago, we have received, after an application that we did, funding from the City Council of Barcelona to create a new campus that would not be just an educational campus. Our proposal is to create what we call an urban tech hub. And the Urban Tech Hub Barcelona, which is going to be the new campus of IAC, is going to be this exact, let's say, merge of creativity, exploration, research, academy, with the world of entrepreneurship, with the world of industries and the world of, let's say, creative minds that they are working on creating this new business model. So I think that this is also something interesting, the fact that the cities administrations are also foreseeing and supporting the fact that we need to rethink even, how our campuses are or who is inside these campuses and how they operate.
And of course, you also have online programs as well, which is a kind of another form of, let's say, campus. And to my mind, actually, a much more efficient form of campus in some senses. You haven't got to the environmentally, not you haven't got to come to campus. You can go online, and you're much more nimble in some ways. One thing also, just to pick up on this, I think another kind of similarity between Digital Futures and IAC is that you're not part of a kind of a very slow-moving academic machinery. I mean, you're much more nimble. IAC is able to very quickly change and adapt to the world around us. Likewise, in Digital Futures, we can literally, within a week, we can propose a discussion and have that to happen. And it seems to me that's also quite vital. And part of the problem is with this kind of the very slow-moving, laborious, and monolithic machinery of the academic institution that is so slow to change. And what if we should move on to Joseph, who is actually who's now just become the director of an institution that has been around for some time, an institution that actually has quite a reputation already for AI, not necessarily in the School of Architecture, but certainly in the School of Architecture, a number of very dynamic individuals who are now pushing the forefront. Joseph, it's great to see you. Welcome.
Thank you, Neil, and thank you for that introduction. All right. So as Neil mentioned, I'm the director of the School of Architecture at Florida Atlantic University. We have a 5-year professional Bachelor of Architecture program. And a couple of years ago, we became one of the first schools anywhere to require all of our undergraduate students to learn artificial intelligence at an advanced level as a requirement to become a professional architect. And the reason for that is because I see it as an ethical obligation. If artificial intelligence is going to be transforming the future of practice, education, and industry, we want to make sure our students are not obsolete in 10 years or in 5 years. In fact, we want our students to be the ones who are help shaping that future. But that said, I'm not just going to be showing you today that particular required studio, but I'm going to show you the entire sequence from first year through 5th year and how we've had to rethink the entire curriculum based on the introduction of having a required studio on artificial intelligence. So the topic of this talk is integrating AI into a professional architecture program. The general vision for our school is to combine and blend innovative research methods with professional practice constraints. That said, how do we teach that kind of rigor? So in the very first studio, the freshman studio, which I teach and coordinate, students are introduced to computational thinking and making. Here, you can see an example of using the carpenter's ellipse, 2 pins and a string. But as you change the location of those pins and you change the length of those strings, you essentially create an analog parametric model. And then the students create these drawings, which are also representational abstractions, which teaches the students to see that which is beyond that which is literally there. So they see more than ellipses, they start to see spatial conditions and boundaries. It starts to help generate ideas. Then they also start to learn about things like shapes carving shapes or Boolean operations. And they have this digital analog workflow. Then they get into an exercise called plane surface volume, where students are introduced to folding. And then from there, they get introduced with curves with lines or ruled surfaces. And again, there's this back and forth between an analog and digital workflow, but students fundamentally learn about how constraints are design opportunities and how they start to create rigor within those constraints. Then they start to analyze the artifacts that they had made, which are these objects to think with and understand the spatial conditions. But at the same time they're doing these abstractions, again, the vision of the school is to combine innovative research with professional practice. We then ground it in reality. So here's a building by Brooke Scarpa. Jeffrey Huber, who's one of our faculty, a professor of architecture with us, this is one of his buildings as well. So our students get to go see a ruled surface in person in our region. They also get to see these projects under construction, but they also learn about historical examples like this one here by Eladio Dieste, which became using surfaces like ruled surfaces as a means to create structural depth, as a means to have a material efficiency, and as a ways to reduce costs in the construction. And so in the first semester, a sketchbook looks like this. But then in the second semester, sketchbooks start to look like this, where students are exposed to other normative constraints, things like this, modeling masonry constructions three-dimensionally. But then after doing this, they then start to challenge those kind of constructions and going back to this abstraction of using the wireframe or the X-ray models to see how they might be able to create heterogeneous space or different kind of spatial conditions like you see here. And then even when they start to get into the actual drawings of the work, if you look at a floor plan like this, you can see the systematic rigor and the kind of heterogeneous space between the ruled surface roof, the Booleans that carve, the simple kind of utility bar building inside that space. In the second year, for both their theory course as well as when they get into their design studios, that's coordinated by Dr. Heather Ligler, who's one of our newer assistant professors. She has a background in shape grammar, so this is some of her research where she's using shape grammars to understand the work of Portman and how she's able to create a series of variations of that work. So in our Theory 1 course, instead of students reading about architects and writing about architects in a traditional sense, it's been rethought as students are each student is given 2 Paul Rudolph houses, but then they have to analyze these houses through a series of operations using shape grammars to demystify the rules behind those floor plans such that they can recombine elements and redistribute the rules to create 2 fakes of that building or 2 new variations. This is really important for the future of artificial intelligence because later when they start to take a studio on AI, if we feed that AI a floor plan, it just sees it as an image. Then you can tell the AI that's a door, that's a window, that's a column, and it understands that. But if you can describe a floor plan through an explicit set of rules, then that AI or a machine starts to understand the ordering logic, and you can have a very different kind of collaboration between the two. And then when they get into the third year, here again, they're starting to use shape grammars in a more analytical way. And this seems quite fundamental looking at a Palladian villa or 2 kind of Charleston vernacular architectures. But later, this becomes the workflow of that student. And here, it really is it's not just necessarily like the way we would think of traditional shape grammars, but it really is a workflow. It's kind of really digesting in a meta-reflection of the different steps that happen in the process. Some of these things happened before as a series of rules to generate operations. Some of them might have been happy accidents, and they went back and then rewrote the rules that started to establish the next steps moving forward. And that resulted in architecture like you see here and here. And then this starts to become the foundation for in 4th year in the fall semester when they're exposed to artificial intelligence at an advanced level. And this is a studio coordinated by Daniel Bologen, who's a leading expert in artificial intelligence. So students create 3-dimensional data sets using algorithms. In particular, this example is using stigmergy. They learn how to interpolate those 3-dimensional data sets using self-organizing maps. And they understand how, based on the inputs of those self-organizing maps, they can even change the weight of different inputs. And they're also, again, similar to the first year, they're able to look at these abstractions and see design possibilities, see opportunities for architecture. From there, they start to, again, these are the self-organizing maps using 3D data as an input and an output. Here's a site analysis example for the High Line. And now here they start to look at the party diagram of the building. They start to look at interstitial spaces and spatial boundaries. They begin to look at unit types within the system. And then here, the AI in relationship to the floor plan generation and this kind of back and forth feedback. And then we start to get something of a spatial proposition and with different kind of architectural consequences for a building. And for me, it's not so much about the results of these images. That's not really the critique. That's not really what's actually important. What's actually important is the way that these students are being exposed to the idea that instead of designing a building, I'm going to design a workflow. So again, my colleague Daniel Bolojan believes the future of artificial intelligence is not just one mega AI, but the idea that there'll be thousands of AIs. And one of the roles of the architect will be to how do we stitch these together and design the workflow between them. Here's an example of one of those interstitial spaces where the spatial boundaries are defined through the AI collaboration. And then here's another example. And again, this starts to show the really way in which the authorship starts to lie partially in the design of the workflow. And then here you can see in this example, some of the process is quite similar, again, using these self-organizing maps and these three-dimensional inputs. But this particular group of students, it's not so much that their methodology was that much different, but the way in which what they were looking at, that they looked at it in a very different way. So instead of necessarily looking at this as a means to generate a building form, they were looking at their building typology, which was an office building typology. And they said, how is what AI is giving me, how can it transform the way I think about that typology? So for them, it started to transform this idea that maybe an office building is not exactly what it typically is, but maybe it becomes more about inhabiting a landscape, which became what we see in this section. So in the end, the AI helped collaborate in the design of this section that you see here and here. So it became more about an idea rather than just necessarily a form. Here is Kathy Velikov, the Associate Dean for Research at University of Michigan. She's on an advisory board, and so she came to the final reviews. And here she's talking about the architectural possibilities of that section and how they couldn't have gotten there without that collaboration with the AI. And again, for me, this is fundamentally really interesting because the AI is actually helping them generate an idea that challenges the typology of a building. This is an example of Daniel Bolojan's research. And so here you can see within his control of keeping the boundary condition of the massing consistent, but then seeing different kinds of spatial opportunities within those massings. And again, for me, when you see where this pauses, that's extraordinary. And it even starts to question and suggest new ways of thinking about structure for a building typology like this. So that said, when we get into the next semester, students start to look at structure. This is a studio that's coordinated by one of our new faculty, Dustin White. And so here students are going back to more of this analog computation in a relationship to Kangaroo and Karamba physics-based engines where they're creating these tensile structures. But what's important here is the image on the left. Each of those students, one by one, placed that model in the space, taking turns, such that the model related in some way to an adjacent model. And then they had a chance to each of them one by one to reconfigure them one more time, such that it worked like a diagram. And in many ways, this became an analog self-organizing map. And by making an analog self-organizing map after they had done one with the AI, made them have a different understanding of what that was in the previous semester. And then again, similar to the first year, these become a series of objects to think with, to question what the future of architecture might be. And then again, I said this was coordinated by Professor Dustin White. So this is some of Dustin White's work where he's generating an architectural aesthetic with artificial intelligence using text-to-image-based AI. But the real authorship is on how he takes the workflow to take that image and turn it into something three-dimensional. And in this case, this is something that has been created through additive manufacturing with stone aggregates. And this is 6 feet tall. And so when we start to experience the details of that, it has a very different, we start to gain a very different experiential understanding in comparison to just the image that we saw before. And now this is an example in the spring of the fourth year, where the student isn't using AI, but you can see from the nature of this work or in this section that that systematic rigor is still very much embedded within the process. And so when we get to the fifth year, we see some work that looks like this, where it's using normative architectural constraints as design opportunities. And we get to this kind of integrated level or comprehensive level of a building. But then we also see in the fifth year students who do this, where they're really starting to design the workflow itself. They're no longer given a workflow, they're actually designing the workflow. And this is a studio that was taught by Dr. Sharmeen Youssef. And it also included a workshop which was taught by Daniel Bolojan. And so these students were interested in the idea of mycelia growth and the idea that imagining the future where a building will grow like mycelia. So they were creating three-dimensional data sets, again, interpolating those. And so this entire building or proposition for a future of architecture that's growing was generated through artificial intelligence, no manual modeling. And for me as the director, I'll be honest, I'm actually not so interested in this, but I'm also not so interested in the comprehensive model. What I'm interested in is how does the comprehensive model start to engage more research and get closer to this? And how does this start to embrace more pragmatic constraints to get closer to the comprehensive? How do we understand the space in between those two? And how do they start to inform each other so that we can really advance the discourse of architecture? I don't think it's just one or the other. I think the two have to constantly be in conversation with each other. That said, we also have to then teach students how to do research. So sometimes we do courses which are research through teaching, teaching through research, where students collaborate with the faculty on an applied research project. And this is a quick example. This is a project where we had an industry-sponsored research agreement with Google. We had a total of 8 executives come to our campus in Fort Lauderdale and Boca Raton. That included their vice president of user experience, and one of their directors of UX actually came 9 times to our campus that academic year. And they simply wanted us to challenge the idea of taking research out of their corporate headquarters and engaging the public directly by making lightweight deployable structures. So here's the deployable structure which we designed. It's 30 feet in diameter. And when it folds, you create a pop-up structure like this, which is spanning 22 feet with a material thickness of just 1/16 of an inch. The other question is, if we are going to be embedding more research into our courses as a requirement for being a professional architect, how can we transform design studios into research labs? And so this was our first vision for a creative AI lab, which would be directed by Daniel Bolojan. So we have an immersive projection, we have AR, VR equipment, we have 3D scanners mounted to the ceiling to allow the digitization of physical artifacts. And here in this animation, we're looking at salty urbanism or sea level rise and starting to delaminate all the big data and spatialize all the big data associated with that, such that that data can become a design tool. One thing I also want to point out is that animation was also made by one of our 4th-year undergraduate students. This is how the AI currently looks today. And so now we're at a phase where we're starting to install all the high-tech equipment on the ceiling. And so this will be completed by the end of this month. And then here, so there are the students starting to already enjoy this space. And they said, it's like a ride at Universal. Isn't that wonderful? You know, artificial intelligence, when you really dive deep into it, especially the advanced level of it, it's quite challenging technically. But for students to be laughing, having a great time when engaging it, because suddenly the space itself is an instrument to think with, is really a cultural changer for how we start to think about integrating AI into the studios. And then the other research lab, which is currently under construction, is the Environmental Design and Natural Materials Lab, which will be directed by Dr. Sharmeen Youssef. And within this lab, we'll have 2 robotic arms and a materials library. And the thought here is that students will do a simulation of a new bio-based material, maybe for an interior finish. They'll then make that material. After they make it with the robotic arms, they'll then test it and then bring it back into their simulation such that they can understand how it's reducing the carbon footprint of how we build. And this will start to transform how we teach environmental technologies within our core curriculum. And everything I've shown you so far today is really a work in progress. And I'm proud of it being a work in progress because I believe a School of Architecture is a design project. We need to keep iterating and we can't be fearful of the unknown. Thank you very much.
Thank you, Joseph. That was incredible to see that vision taking life in FAU, Fort Lauderdale. I mean, one thing I thought was thinking was actually, in some ways, you're offering the model that I'd hoped would happen when I was talking about IAC, that the idea of IAC would cancel itself out, that everybody was going to be incorporating this into every single school of architecture. But of course, that never happens. In fact, you get this extraordinary resistance on occasions. I mean, I was a student at Cambridge in the 80s, and we had professors, no names mentioned, who would ban the computer from the studio. They would ban the computer from the studio. Now, the smart students would all work on the computer, then they would do some overlay and this kind of fuzzy drawing and pretend it was a hand drawing. And the weaker students would not do computer drawings, and they would go out into the world. And frankly, there was a whole generation that came out that was unemployable because the office world had completely transformed and adopted computation. And there we had graduates that were going the wrong direction. And I can't help thinking in terms of your own alma mater, how that MIT, how that model of progressively trying to rethink how things are operating is coming to fruition in forms of, it's called MAD, the new institution that combines all different forms of design into a single kind of curriculum. And we really, I think that's, to my mind, seems to be the way forward, creatively rethinking every day almost what we need to do, responding to the challenges. And almost the opposite model seems to be going on down the road somewhere that I used to teach at the GSD, where they're kind of reverting back to architecture with a capital A. It seems to me that architecture is a dynamic entity. It's continually moving. I always think it's like a shark. If it stops moving, it dies. It is continually moving, and it needs to respond in some ways to the challenges that are coming up on an everyday level. And I think the idea that you're integrating this not as an add-on extra, but as really what we need to have for the future is fundamentally the way forward. But I just want one question. We haven't actually, you were talking just about the design studio. How does the world of AI begin to incorporate itself within the theory, in the theory, the history, and whatever else, the other side of the academia? I mean, at FIU, I've been teaching for a few years now a theory of AI class, which is incredibly popular. I mean, it emerged because I found all my students writing about AI. So I think, let's make the course about AI. But the challenge becomes, once you've got ChatGPT that can write your essay for you, how do you write essays and how do you even teach design? And so what I've done, and this is experiment in many ways, just to kind of adapt to the world that is changing. This last semester, I said, okay, we're not having essays. But I want you to use as many different forms of AI as possible to put together a video in a critical modality to try and say something in that kind of way. And it proved to be quite interesting. But do you actually engage? Has the world of AI begun to impact upon the kind of the theoretical debates going on in the school as well?
Yeah, so I would say it has influenced in different ways. Obviously, it's part of a regular conversation between our faculty and our students. And it's ongoing in kind of, some who are practitioners understand it from a certain kind of pragmatic perspective. Those who are more traditional academics who have certain kind of scholarly work in computational design, they look at it more as a projective way of seeing new ways of thinking that we could not have thought about before. But then even within the context of one of our from our historian perspective, Dr. Willa Granger, she was the one who actually came to us and said, we have to actually have a syllabus template that says, this is a time for a course where you actually are not allowed to use AI for a specific reason. This is a course when you can if you want to, but then you have to cite the use of it. And this is when it's actually fundamentally required to use the AI. And so even within the curriculum, there are moments when we might actually say, actually, for this portion of this kind of scholarly education, we don't want you to use AI because it doesn't mean that it's replacing everything. It's basically adding to the way in which we can think. But that doesn't mean that we don't necessarily want them sometimes going physically into a historical archive, as an example. And so it's similar to the way in which even when I teach computation at the first year level, sometimes we do things intentionally as an analog way. So when we do the digital, it demystifies how the digital tool works. And so I think it's kind of this back and forth. I don't think anything that we're doing, Neil, is perfect, But that's also the point of it, is that we're really not afraid of the unknown. We are embracing it. And if we don't think about it as having to be perfect, then we just can keep iterating. If you try to imagine all perfect ahead of time, then you get nowhere.
I mean, you also have a doctoral candidate who's working interface between historical archival research and AI, working partly with the computer science department as well.
That's correct. So we have a PhD in design aesthetics and the arts, and some of those individuals most of them are all doing applied research, but many of them are using either advanced computation or AI as part of that. Some have more of a focus on kind of cultures of making, some have more of an interest in kind of advanced manufacturing or material innovations, and some like the one in which you're mentioning there have a focus more on how do we use AI to change the way we understand history and construct new understandings of that moving forward. And I think it's really exciting. And again, it's multifaceted, it's polyvalent, it's not just one-dimensional as a future. There are many futures for this.
So thank you. Let's move on to Behnaz Farahi, who is actually in some ways embodies this kind of model, let's say, of an architect, someone with an architectural background who is adapting to a kind of new world. And I mean, one of the things that Behnaz and I did together was to produce an AD on 3D printed body architecture, where we noticed that those coming out of an architectural background, figures like Nicolo Casas or Neri Oxman were actually working with the world of fashion and doing 3D printing for these individuals. In other words, what we could see were there a series of what we call other architectures, other professions that or disciplinary areas that from our own backgrounds as architects, trained to think three-dimensionally, trained to understand material behavior, and trained to design, could shift. And it's not just the world of 3D printing, it's also the world of space. Space architecture is full of those with architectural background, and indeed the world of the cinema. There are many different ways in which these other architectures can appear. So Behnaz has come from an architectural background, currently teaching in a design school. Behnaz, welcome. It's great to see you.
Thank you, Neil. Hello, everyone. It's a great honor to be here and be among such great lineup of speakers, friends and colleagues. So I'm delighted to be here. Let me quickly share my screen. And I just want to, while this video is running in the background and I introduce myself, I want to quickly actually show the work that I've been doing with my students. So this presentation is mostly focused on AI and education, but I thought to just like quickly introduce myself. I am coming from Iran, and currently I'm assistant professor of design in Cal State Long Beach. And my own work has a lot of intersection with physical computing, artificial intelligence, robotics, architecture, fashion, and interactive design. And I'm really interested in my own practice to explore how we could see these artificial intelligence system could act as an extension of the human body to enhance our perceptions, ways of communication, or in fact, our social interaction. In California State University, Long Beach, I have set up a robotic lab called Emotive Robotic Lab. I'm also co-coordinator of the graduate program called Human Experience Design Interaction, which is a 3-semester graduate program, a very interdisciplinary program. My lab is specialized in integrating robotics into the field of design. It really kind of delves into the human-robot interaction, robotic fabrication, digital design, the use of generative AI in design, and really exploration of cutting-edge materials. We also look at materials as an initiative for design research with a special interest into robotic fabrication, including 3D printing, clay 3D printing, plastic, liquid, photogrammetry and 3D scanning, algorithmic design, and obviously AI. But what I want to really emphasize in this presentation is that, especially teaching in this graduate program, I would like to share that I have a lot of our graduate students coming from many non-design backgrounds, including psychology, sociology, sometimes anthropology, computer science, mathematics. So this can be really sometimes a challenging task because for them, they're not familiar with the design culture. Having said that, we all know the sort of importance of this interdisciplinary thinking. It's wonderful. Sometimes the ideas that they bring on the table is very unique. But how could we enable this group of non-designers to really enable them to be able to express their design ideas? So this semester, I'm actually offering a course. Sorry, this semester, I'm actually offering a course called Generative AI and Robotics, where students sort of work with a variety of generative AI tools and for production of ideas. And one really wonderful aspects of this, obviously, like the first 1/3 of the semester, the students just producing concepts that can really go across the scales from fashion to objects to architecture to urban interventions. And I think that the accessibility of this tool for raising ability for creating concepts for across the scales design, I think is stunning. We also look at how we can not just use 2D AI generation tool, but how can we quickly move on to 3D by various methods that we can, sorry, I'm gonna stop the sound, by various methods that we can really move from 2D AI generation to 3D. And then apply some of the sort of robotic fabrication, either robotics or multi-material and multicolor 3D printing for printing the outcomes of these AI-generated items. So this workflow is something that I love Joseph's emphasis on the workflow. And this workflow is obviously something that is very custom-made, but the students are able to sort of understand what are the steps that they can take to design a workflow. As soon as they have this workflow, then by just quickly changing the image, now they have different outcomes. So we really look at in one hand, using various generative AI tools to generate concepts. And then on the other hand, we really look at how we can move away from 2D to 3D and produce sort of 3-dimensional outcomes that finally can be 3D printed in a tangible item. Again, in this case, students look at use of Midjourney for generating image, applying process to make it to 3D, and then after that using multicolor 3D printing this material with all its textures and material properties. And these are some other examples where you can see examples of how the process between photogrammetry, 3D scanning, production of the image using Midjourney, and then actually fabricating it using multi-material 3D printing is taking place. And I want to again emphasize that some of these students are not trained as architects or designers. Some of these students are absolutely coming from backgrounds such as graphic design, which is absolutely 2D design, or even non-design backgrounds such as sociology and anthropology. And yet they were able to sort of understand the process and allow them to produce these outcomes. Another aspects of the work that I do with the students is not just production of objects, but also production of use of generative AI for creating immersive experiences. So in the next slide, that is my last slide that I'm going to show, the students actually use AI generative tools for creating 360 interactive experiences using content that is generated in AI. And by including sensors, they create interactive experience. In the next slide, you see the example that they wanted to raise awareness about environmental crises that face our ocean. So I'll just let you watch that. So in this case, the sort of content that it was produced, it was all generated in AI. And they use Arduino for making this process interactive. And so the use of AI in this case could be also used for production of VR, 360 experiences, sensory experience design, which is very incredible also tool for again, students that they're coming from non-design backgrounds. Maybe to wrap up, I would like to point out a few things here. One is that it seems to me that, especially in the context of education, AI could open up a lot of opportunities in terms of accessibility. And as I showed in these examples, I personally noticed this because a lot of my students come from non-design backgrounds. So it's really sort of a question of how, if you're coming from, let's say, psychology or anthropology, how could you use these tools for expressing in a visual way your ideas? And I think the question of accessibility has become really important because it actually enables people to be able to express their ideas in a very novel ways. I also think that this also changed how we have previously felt about being included or excluded in the discourse. Now, many times, especially with in the context of how where you born, which part of the world you're actually born, you might have access to certain tools. But with accessibility of these tools, you're able to actually produce more content. Now we can discuss the sort of the fact that yes, with many of these tools you have to pay subscription. In many countries you're not able to even pay, but a lot of these tools are also open source. A lot of these tools still allow you to produce content. So I think the accessibility beyond border is something that it also is an interesting results of these generative AI tools. It would somehow move toward leveling out the level of access, not for just between designer and non-designers, but also between West and East, between different sorts of geographical location in the world. And also, I would like to maybe say a few words about the context of, I'm going to stop sharing. I want to say a few words about labor. Again, as designers, we're all aware of sort of the culture of all-nighters. We all stay late for the nights of producing sort of a concept to finish a project. So the question of labor and the process that goes behind the process of ideation to production to rendering, a lot of time requires a lot of intense processes. With the advances of generative AI tool, this process is going to be very different for our students. I am wondering if this means less of sort of all-nighters cultures, or how that culture of like a studio culture would be different with the question of AI. We already can see that the students don't need or don't require to spend hours and hours for their rendering. In fact, they can just put it in one of these AI-generated tools and they get renderings by just writing prompts. I'm not saying that this process is absolutely not labor intensive. It requires its own labor. Having said that, it seems to me that it's substantially shorter. So it will substantially change what it means to be a design studio student. And at the end, maybe my overall thought, and here I really agree with Areti in terms of co-creation, the process of co-creation with AI is something that is very, very important. We shouldn't see these tools, generative AI tools, as something that's going to replace our human creativity, but we really should see as a collaborator, as something that we are just starting to learn how to collaborate with, how to be partner with, how to really tinker with these tools, how to express ourselves in new ways. So if we look at them as co-creator, as co-collaborators, we just have a different paradigm for working and educating our next generation of designers and architects. With that, thank you so much.
Thanks, Behnaz. That was fantastic, and it's amazing to see what you can produce at a design school with people who haven't got a background in design. That was truly astonishing. Just as a kind of point of information, it's maybe you're not unaware of this, but actually the point you made at the end about the all-nighters was actually one of the motivations behind the introduction of AI, at least for one part of one person. Wan Yu He, who was working for OMA, she worked first in Rotterdam, then in Hong Kong, and the Hong Kong base was in Lang Kwai Fong, which is a nightclub area, and they found themselves upstairs working late into the night and often over the weekends and things, and often on all-nighters, while downstairs they were partying. And Wan Yu's response was, "This is insane. We've got to find a much more efficient way of doing things." So hopefully all-nighters will be out of the window. But one thing I find interesting is in terms of AI, there are two different modalities, it seems to me. I was writing about this in my book. One is that on the one hand, a lot of this technology make things much easier. I mean, just sort of swiping on your iPhone, they're very intuitive gestures. You haven't got to know so much about things. And we've shifted from a world where you would have to do scripting into the world of Grasshopper, into the world of Midjourney and whatever. Things have become, in some ways, much more accessible. At the same time, of course, you do need the kind of Daniel Bolajans who will get under the hood and start sort of working with the technology and pushing things. But what I find interesting is that there's almost like a new modality of operation whereby, because you don't need that technical expertise, and because actually in some senses you don't need to be quite the same genius curator of the past, because Midjourney's pushing out these ideas, you become more of a kind of curator in some senses. But you have to have an eye for things. You have to have an eye. I think someone like Nicolo Casas is so good because he knows how to discriminate, how to pick the right thing out of things. So the question is, ultimately for you, is how do these design students, how do you see that operating? I mean, could you say they're becoming more creative or more design conscious, or do they have a different modality to typical design students? How are they different to the standard? I don't know, the people that you were trained with a School of Architecture in terms of their adoption of these technologies.
Yeah, I think you're pointing out a very important question. I think that that's why I think the conventional still design and architecture background is not like obsolete, is actually still required, because we do still need to develop the sort of design sensibility. And I see that in my students, that I have to be the one that I select them or aim, like sort of like direct them to make sure that they can go to the good process of selection in a way. Because you're right that, I mean, except very few, that they naturally maybe have more sort of aesthetic or visual sort of sensibility. If you're just trained as like a psychology student and you have no design sensibility or aesthetic sensibility, it's just challenging. Like, how do you want to sort of pick between 4 options that Midjourney would give you even? So I think that's why I think the sort of the concern, the fear that exists, that, oh, this AI system gonna completely replace human or completely gonna replace us. I just think that that's not necessarily make a lot of sense, because I think that the human at the end of the day is within this loop of co-creation and co-collaboration. We are the one that we are still choosing, directing, and deciding which direction to go. So I see the role of designers to become part of this process, and I see the role of education to still being able to educate our next generation that design sensibility, which perhaps come from sort of historical context, understanding what has been done before, who are the people, what they have done, case studies that would allow them to understand that, oh, this is a design language. So education is becoming important to develop that language, I would say.
I mean, the interesting thing about design is that we actually don't really teach it. I mean, you just absorb it. It's a bit like a language, actually. You pick up a language by being surrounded by people then speaking a certain language, and also with a certain accent, you pick up the accent too. And it seems to me that architecture, there's very little explicitly taught. There's more kind of almost like a process of osmosis. You're in a culture, an environment where people are, pointing to certain things. So it makes it into a challenge. How do you? What you're saying essentially is we need to develop these We need to develop an eye, for want of a better word, a sense of being able to discriminate, to be more curators in some sense. But to be curators, you've got to be a discriminator. You've got to have a good a sense of judgment. But how do you teach that? Of course, that becomes the interesting challenge in many ways. Let's move on to Philippe Morel. Philippe I mean, we've just had interesting examples of Joseph Choma, of course, trained in a very famous school, but teaching in what hadn't been up until now such a significant school of architecture. But I think FAU is now turning to something interesting. And Behnaz also coming into a design school and shaking things up in an interesting way. Philippe, by comparison, is now working an associate professor at the Bartlett. One of the world's, in fact, that recently won the vote of the top school of architecture in the world. So very much a different situation. And also directing this program, which is an astonishing thing in itself, looking at computation and architecture. Philippe, it's always a great pleasure to have you here. Welcome.
Thanks a lot, Neil, for the invitation. Thanks a lot to all the Digital Future team. It's always a pleasure to be speaking with great colleagues who are, by the way, always looking further to improve the quality of architectural education, and not just education, by the way, but the architecture at large. So basically today, I will try to quickly address a few questions associated with artificial intelligence, but also with what I called like a year ago for the first time, at least for me, artificial architecture, which I believe will become ultimately the only natural way to do architecture. So basically, as Neil said, I'm directing the Master of Science in Architectural Computation at the Bartlett School of Architecture. We have amazing colleagues, amazing students. It's really a great pleasure to be teaching there. And we always try to address the most provocative questions. Recently, we moved towards an almost 100% artificial intelligence-based research. Let's say all of our students work with AI tools, and they try to apply this on many different levels. But we will see this further on. Just as an anecdote, because I received this email with my colleague Julian very recently, as you can see on the 24th of March, and our student, an old student of us, said, as you can see, so I show it here because it's more readable. He said, "What an incredible year the past year has been for AI and architecture." I remember when we first entered RC11 2 years ago, it was in urban design. I was also teaching in urban design at that time. Said, you told us that the future of architecture is 100% about artificial intelligence. At that time, we were half believing it. And then after a year of learning, we deeply agree with this idea. Today, in just 1 year, it's shocking that everyone in the construction industry, no matter how traditional an architect or a laborer, is now convinced. And then the student is letting us know what he did in this last year. He went to work both in a traditional office, but also in a more advanced company with looking for the application of AI technology in the construction industry. Here, I removed a bit of the information because I just did not want to put my ex-student into trouble by showing showing let's say sensitive information. But basically, it's clear that artificial intelligence today is becoming the core of many different things. Still, beyond ChatGPT, Midjourney, and also different kinds of tools that are also now more and more embedded into advanced software solutions, I believe it's necessary to address a couple of theoretical questions, and that's what I'm trying to do, and also what we are trying to bring to the student, both, I mean, these questions, but also possibly some partial answers. So we all know that what we are speaking about today, when we speak about artificial intelligence, it's definitely not the good old-fashioned AI, which was symbolic AI. It's much more about the connectionist model, and more specifically, the connectionist models that are associated with the application of neural networks that were invented by these two guys, Warren McCulloch and Walter Pitts, but also further developed by Frank Rosenblatt. He was, I mean, we know when we look at the history of AI that Frank Rosenblatt's work was dismissed because it was supposedly not able to address specific nonlinear mathematical problems, which was right, by the way. But thanks to the addition of extra layer, we now know that we can do that, and thanks to deep learning, we can address amazingly complex mathematical problems in an amazing amount of dimensions, not just 1D, 2D, 3D, but really like millions of dimensions, mathematically speaking. So basically, when we speak about AI, some people are rightly asking the question, what is it? I mean, obviously we can say, oh, it's ChatGPT, or it's deep learning. It's about machine learning. It's about the learning based, I mean, training algorithms based on massive amount of data, etc., etc. Right. I mean, all of this is partly okay, but ultimately we don't really answer the question, what, mathematically speaking, artificial intelligence algorithms, especially the one used in deep learning, are doing. So for some people, ultimately, it's just like plain old basic interpolating functions at an higher level, and this is what Jan LeCun mentions at some point, but in a critical way. He says that for people, deep learning is not as impressive because it's just mere interpolation, resulting for glorified curve fitting. You know, as I said, like old-fashioned approximation, which allows in many dimensions to identify data, etc., etc. This is fine, but ultimately, when we look at the amazing things we can do with artificial intelligence, the fact that we can deal with many different kinds of problems in architecture, but also, for example, here, as we see in the students' thesis, you know, these are a couple of theses from last year in the architectural computation Master of Science program. And when we look at the title, reinforcement learning, deep Q agents, learning differences within Poincaré hyperbolic, blah, blah, blah. Architectural sketch to 3D form a human AI collaborative design workflow, exploring the visualization of sound, machine learning classification of urban sound and its visual dynamic representation, or automated architectural modeling, a generative design toolkit for architectural 3D models using generative algorithms. So basically, when we look at that, we see that AI is capable of doing many different things. Some of these things can be regarding the work of our student, it can obviously be seen in the yearbook at the Bartlett School of Architecture. But when we look beyond the discipline of architecture, we know we can do quantum chemistry with machine learning. So then the question is that, right, it could be described by some people just as glorified curve fitting. But first, according to Yann Lequin, in high dimensions, there is no such thing as interpolation. In high dimension, everything is extrapolation, which means that this problem of extrapolation is, again, according to Yann Lequin, a much harder problem than just curve fitting. So basically, it seems to me that the student needs to understand not just what we are doing with AI tools, but it's very interesting and very important that they also try to understand on a more mathematical level what does it mean, let's say, mathematically speaking. What are we doing when we are making use of such or such a software tool which is sometimes available online? And I think this is the first question I want to address with the student, is that at some point we need to understand what it is on a more fundamental level, and if, according to this amazing researcher Andrew Stickley, if AI is not about curve fitting, then what is it doing? You know, and this question might seem quite easy, but it's obviously a very difficult question. We know that our students who are not mathematicians, they won't come with an answer to this problem, but it's not so much, I mean, it's not a problem in itself. What's important is that at least they understand the importance of that question. The second thing is, what is the role of architectural knowledge and architectural theory regarding the current situation and the current explosion of artificial intelligence tools in architecture? What is the relevance of this classic old 20th century book in architectural history or architectural theory? What is today's importance of this critical books from postmodern theory, for example, or this classic book by Charles Jenks about the language of postmodern architecture? In fact, this is important to pay attention to some of the concepts that are, let's say, put forward in this book. For example, the concept of language. It's still important because when we look at the critics of ChatGPT, one famous critic comes from with arguably one of the best or one of the greatest linguists in 20th century linguistic. And he is a real scientist, so let's say he understands quite well or really well what artificial intelligence is about, mathematically speaking. So we need to pay attention to the critics of Noam Chomsky. So basically, Chomsky used a critic which is a linguistic-based critics. According to humans are limited in the kinds of explanation we can rationalize, conjecture, but machine learning system can learn both that the Earth is flat and that the Earth is round. They trade merely in probabilities that can change over time. So for Chomsky, when we use words, obviously we are making use of syntactic construction, but these words also have a meaning. And we cannot learn, or we cannot affirm state at the same time that the Earth is flat and that the Earth is round. I mean, either one of the other needs to be true or false, basically. And what is the problem for Chomsky is that the artificial intelligence system gives us an answer to this problem only in terms of probability, but not based on scientific explanation and theories. It's an important critic, and at some point it's a relevant and true critic of the AI system. But at some point, Chomsky is not entirely right. He said, for example, that some program cannot explain the rules of English syntax. For example, ChatGPT may well predict incorrectly that John is too stubborn to talk to, means that John is so stubborn that he will not talk to someone or other, rather than he is too stubborn to be reasoned with. So I just made a quick experiment on that. I asked ChatGPT, okay, what does John is too stubborn to talk to mean? And at some point, the answer either from ChatGPT 3.5 or ChatGPT 4 are perfectly valid, you know. So it shows that some critique by Chomsky, which is based on the role of science, basically. I mean, it's no less than the importance of science and truth, or let's say scientific truth. So some critics of Chomsky are right, but some critics by Chomsky are plainly wrong, because ultimately, when we just make the test, we see that ChatGPT is giving us the real answer. But is it because ChatGPT really understands the meaning of this sentence, or is it because ChatGPT is so amazingly good at playing with probabilities? And obviously, this question at some point is still an open question. Another critic by Chomsky says that the human mind is a surprisingly efficient and even elegant system that operates with small amount of information. It seeks not to infer broad correlation among data points, but to create explanation. True intelligence is demonstrated in the ability to think and express improbable but insightful things. And here again, we go back to the problem of patterns, because patterns is what AI current system are playing with, and it's a concept which was really important in the architectural series in the 70s. But still, the way this concept was used in the 70s is fundamentally different from what is done today. And in fact, the concept of pattern in the 70s strangely led exactly to the good old-fashioned AI and to that end. The shared grammars paradigm also in architecture was super interesting, but at some point it also showed some limitation, which we all know about today. So basically here, we need to reread the old architectural theory with the eyes of I mean, based on what artificial intelligence can bring us today. We know that theorists, in order to overcome the limitation of symbolic logics and symbolic thinking, they also tried to address the issue of emergence, of movement, etc., etc. But today, these concepts are of, I would say, almost of no use when it comes to a deep understanding of what's happening in artificial intelligence today, at least according to me. But still, some concepts are relevant. For example, the architecture without architect is a concept which is more relevant than ever, because more or less anybody can now just like play around with those things that he or she believes to be architecture. So we need to understand the issue of architecture beyond form, beyond the old concept. It's something that I tried to understand in 2007 in an exhibition I organized, and I think it's still relevant today. Some old concept in architecture from Cedric Price, Nicolas Negroponte, John Fraser are still relevant today. And basically, we need to find new, let's say, new theoretical construct to let's say, to make something meaningful out of the old architectural theory. What is relevant in the old 20th century architectural theory for a better understanding of artificial intelligence today? So language is probably not that relevant. Pattern is relevant, but not in the way Christopher Alexander was let's say, using it. So yeah, but we might need architectural theory. The issue of creativity is an important question. It's an important question until a certain point only, because we entered the, let's say, the age of unlimited creativity, unlimited architectural options. But precisely because of that, precisely because we can end up in this kind of super baroque, you know, this explosion of creativity, this explosion of everything. It kills itself. I mean, the fact that we can do absolutely everything is almost equal to the fact that we can do nothing. So when we look at something which was absolutely creative, for example, here's the open house by Kopp Himmelblau, this absolutely amazing project. Today, if someone come up with this kind of design, obviously it's not going to be considered creative. But if someone come up with something that is even more weird, it's not necessarily it won't necessarily be considered creative as well, you know. So basically the discourse on creativity, even if it's important, I believe personally that it might be a wrong question, because creativity ultimately refers to knowledge and intelligence, which themselves refer to information and computation, and we might better focus on what really happens within a computer. And a computer knows nothing about creativity, but a computer knows everything about information or computation. So basically, creativity might be too much an anthropomorphic question, and we might need to focus on some other problems. For example, the problem of reality. What is reality in architectural and in architecture today? But also beyond the discipline of architecture. Let's consider this extremely disturbing image. In a sense, we could say AI is extremely creative in generating those images. But personally, I'm not really afraid of the creativity of AI in generating these images. I'm pretty much afraid by the very existence of these images. And it has nothing to do with the creativity. It just has to do with the fact that it's here in front of us, because it creates a kind of parallel world, a kind of parallel reality, which is absolutely disturbing at some point. The first question is concerns the role of math and data. famously, Geoff Hinton said that AI will be able to do everything, which is real. And we all know that one of the most important, let's say, cause for the AI revolution we are now experiencing is the fact that we have access to an almost unlimited amount of data. And because we have the data, maybe we don't need the math. For example, DeepMind recently has presented some work for which, I mean, the data-based forecast beats in 99% of the cases the old classic prediction, making use of very complex mathematical equations about fluid dynamics. So basically, if we have the data, we might say we don't need the math. This is something which is part of the theoretical discourse of Mario Carpo. I know that on another level, Neil himself is probably he does not fully agree with Mario on that. And by the way, it's important to have this super interesting debate. When it comes to me, I believe that it might be enough to have the data, right? But even if we have the data, ultimately it ends up in an informational problem, because if we have the data, then data is nothing else than information. We all agree on that. But if we have the data, the question is the following: how much data do we need to make interesting and valid prediction? And this, in fact, is a mathematical problem. It's not a database problem. It's a mathematical problem because the data cannot explain itself. I mean, if we want to explain the problem of information, we need to use, I mean, the mathematics of information theory and many different kinds of mathematics, by the way. But one sure thing is that we cannot extract by magics. It's not possible to create information from scratch. It has to exist somewhere in the world. So if I ask the audience, what is this image? Obviously, for most people, it's absolutely impossible to say who is that guy. Now, if I show this image, most people are capable of saying it's Barack Obama. But think of it in a logical way. I mean, we are capable of saying it's Barack Obama because we have more information. Here, we don't have enough information to say with that guy. Here, we have a bit more information because we can say it's Barack Obama. But in fact, we can say it's Barack Obama only because we have a perfect image of Barack Obama in our minds, basically. In fact, we have some pre-existing information about Barack Obama. And if we would not have this pre-existing information about Barack Obama, we wouldn't be able to say anything about this image. So let's think of it. Basically, we have a very interesting debate about the let's say traditional mathematics, the data, the massive information, the big data. This is a problem that Mario Carpo is addressing, for example. But ultimately, most architectural theory do not come today with an answer to the problem, because when we say that we just need the big data, we are not answering the question. We are not answering the question. We are just saying something that happens on a practical level, but we are not coming with a serious problem. Finally, I want to end up with the question of learning. It's an important problem because when we speak about AI today, we speak about deep learning. So the word learning is, is already present in this expression, deep learning. It's also obviously present in machine learning. So in many cases, and here it's a bit of a contradiction, because you have some people who say, oh, the computers, they need to learn a lot to be able to come up with interesting answers. It's what happens with ChatGPT. I mean, ChatGPT is learning from the world, from Wikipedia, but also for almost the entirety of the internet. And some other people say, oh, but in fact, a toddler need only to see a cat or a dog once, and they can identify any cats and dogs. So basically the question here, as you can understand, I'm not interested in cats and dogs. I'm interested in what needs to be learned by a student in a school of architecture. I mean, if we say that machine learning algorithms need to learn from the entirety of architectural history to come up with interesting projects, then we should ask ourselves, okay, but what about students? Do architecture students need to learn a lot of architecture, basically to capture and digest a lot of architectural data? Or do they need to spend 1 month in a school of architecture, and then it's good enough, they will be able to become great architects in the future? So here, I believe it asks the question of what is intelligence, what is knowledge, and what is learning. And obviously, it goes to the question of superintelligence. We have this connection between intelligence and learning, because if you look at the standard definition of human intelligence in the Encyclopedia Britannica, it says it's a mental quality which consists of the ability to learn from experience, to adapt to new situations, to understand and manipulate abstract concepts, to use knowledge to manipulate one's environment. So basically, we would say a good architect or an intelligent architect or a good student or an intelligent, let's say a smart student, is a student who is capable of learning architecture, if it's an architecture student, obviously. But then what, I mean, what kind of learning are we speaking about? Because now it's not about competing with the old-fashioned architect, it's about competing with machine learning algorithms who learn architecture from the internet. So we know what AI system can learn when it comes to architectural knowledge, and we need to answer the question: what do architectural students need to learn to compete with AI systems? So it seems to me. Very partial answer to this problem, learning by algorithms and learning by humans. We know what algorithms are learning. They are learning from massive amount of data, and we now are almost 100% sure that the more data, the better is the learning. This, at least on an empirical level, this has been more or less demonstrated by the efficiency of the large language models recently. So basically, we need to learn from massive data when it comes to the computer. And ultimately, it's going to be routine to learn from the entirety of human knowledge, because it's going to be available online. So all machine learning system will be able to learn from this. But ultimately, we don't solve the math problem. How we can move from a certain amount of information to another amount of information. Think of the example of Barack Obama. Again, if you don't have in your mind the information Barack Obama, you cannot answer the question, who is that guy? Okay, so it's an important problem. But here, I would point out another problem, which is one of data poisoning. If you don't have the original data, let's say the clean data, you cannot train good models. You know, So I mean, we should not underestimate this problem, because if we as architects don't have good data, we will never be able to make our algorithm learn anything. And we will obviously not be able to compete with Google. Not by humans, because when I speak about humans, I speak about architecture students, basically. What do these students need to learn? Then they need to acquire knowledge, so they need to learn from existing data, yes, but they will never be able to compete with the algorithms for that. So, and I think I would never use this word in my life, but ultimately I'm doing it. I think the student need to learn from experience, but not, I mean, experience not as data, but experience as empathy. I don't want to be romantic about this, because this word for me, empathy, has nothing. I mean, it's not about romanticism. It's about the scientific fact that if we learn experience, or let's say we learn from experience as data, we are never going to go beyond the algorithms, because algorithms are much better than us when it comes to this kind of learning. Ultimately, we need to learn conceptual business models, or to develop conceptual business models. This is what architectural students need to do, and I think this was absolutely rightly mentioned by Areti 20 minutes ago. And we need to make sure that the students learn more math, because the data are not going to be enough. We will need to understand what's really happening in the black box. And if we want to understand what happens in the black box, which is in fact not black at all, I mean, there's a kind of mythology of the black box. We can perfectly know what happens if we have the math, basically. So we need to bring more mathematical knowledge to the students so that they can go beyond the myth of the black box, and that they can really understand what happens under the hood. The problem of data poisoning, as I said, it will come to us very quickly, because in 2030, some people believe that more than 90% of all content on internet is going to be generated by AI, which means basically that at some point, 90% of the content on internet might be poisoned. It's not sure that it will be poisoned. It's just that it's going to be very difficult to distinguish between what is, I mean, accurate data and what has been poisoned by artificial intelligence. And secondly, when it comes to the business model, this is something that I addressed a year ago, and many years ago, by the way, but I insisted again on that in a small publication by Springer about the disruptive technologies and the convergence of new paradigm in architecture. So yeah, thanks a lot. I hope that with these 5 questions, I addressed some of the most pressing issues in architectural education today.
Thanks, Philippe. That was an extraordinary lecture. I mean, really a lot of stuff packed into that. I mean, and I'm not sure we had a chance to really to delve into this. This is actually something I want to go to listen to again several times to really take on board those ideas, because very, very thoughtful. I hugely provocative, some of the things that you were saying. I particularly enjoyed this kind of question, and maybe the term creativity is too anthropomorphic or anthropomorphizing. You know, maybe we need to find a different logic. You know, and information, I think, absolutely is a term that needs to be mined. And of course, that's part of my disagreement with Mario Carpo. I think it's not about form; it's about information. And it was interesting because I was a conference in the University of Miami day before yesterday, and it was very significant that Ali Malkawi was showing the work that he's doing in Harvard GSD, where they've taken an existing building and they've retrofitted it with all these technologies, including a digital brain as such, to monitor the way that it operates. And the idea that the future is going to look like new forms, I mean, to my mind, it's going to be actually pretty much the same. The city of the future is very much the same, but using digital twins in terms of performance questions and using that information in order to make things much more efficient and more sustainable and so on. So the digital twin, which also was in this conference, they were talking about how they were using it now for traffic in Miami, as they have been for some time in China, and how the digital twin's been used to model, to look at the performance of houses. I mean, it seems to me these are the crucial questions about how we go forward. Information is absolutely vital in that. And I think that my problem, though, is in some senses, is that as soon as we use any of these terms, such as artificial intelligence or learning, we automatically anthropomorphize them. That's why I try and use rather disruptive terms like alien intelligence to try and show that the intelligence we're talking about has got nothing to do with that. Maybe it should be alien learning as well. I mean, maybe we need to kind of find a new vocabulary to talk about this new domain, because it is something that is fundamentally different. So it was sorry, Philippe, go ahead.
No, yes, you're right. In fact, you know, what's interesting is that when we look at ChatGPT, for example, when we address the issue of learning, when we speak about ChatGPT, we don't anthropomorphize. At least the scientists were creating ChatGPT-like models. They do not anthropomorphize the learning because it's purely quantitative. I mean, ChatGPT has been trained on a certain quantity of data, and all the relations that are behind ChatGPT are probabilistic relations. You know, I mean, this is the famous tokenization. And the interesting thing is that they don't speak about words; they speak about tokens. And because of that, we take some distance from language, because language is obviously seen as something which is, let's say, far too human. When we speak about language, in many cases, it becomes anthropomorphic. And when we speak about learning, or let's say traditionally speaking, it also becomes anthropomorphic. But when the AI scientists speak about tokenization, and when they speak about the amount of parameters, like hundreds of billions of parameters in AI models, and when they speak about hundreds of billions of tokens from which they learn something, here it starts to become a matter of information and computation. It's de-anthropomorphized. And I really believe that at some point we probably need to do that. You know, I'm very interested in this question. What is the amount of information an architecture student needs to be an architect? You know, I mean, because traditionally we say, oh, we need like 5 years of studies to become an architect. Okay, right. But now let's try to ask this question in terms of machine learning, in terms of ChatGPT. The question would not be, we need 5 years of training. The question would be, how many billions of images do we need to learn? How many millions of lines of architectural theory do we need to learn to become a good architect? So you know, I think it's, I mean, this allows us to ask the question of architectural education in a radically new way, not a culture, it's not about culture. It's really about a quantitative approach of learning. And I'm sure some people will say, oh, no, it's not architecture. Architecture is not about quantity. It will never be about quantity. But some people said the same for language. They said, no, it's not about quantity. It's only about quality. Yeah, but there's nothing qualitative in ChatGPT. It's all quantitative. And still, at some point, it works. Okay, it does not work on everything, but it works pretty well on many different things. So yeah, I really believe we need to readdress some old concept in architecture and consider what kind of information we need to acquire if we want to become a good architect, in the same way as ChatGPT is asking this question for itself.
No, I totally agree that with you on that. And I think, I think Stephen Wolfram, in some senses, also argues we can learn from ChatGPT about how we ourselves operate. And I completely agree with that. I just get one thing I was talking about this conference in Miami was what I find a really fascinating concept, which is the notion of emergent capabilities. That's something that we get out of ChatGPT, that basically it's out of the sheer quantity of the data. It starts to, and I think the term learning is, of course, problematic, but it starts to learn languages, learns codes and so on, learns all these different things. And we can't really explain what these emergent capabilities are and how they operate, just as we can't explain emergence. I mean, Stephen Johnson said that it's beyond us in some senses. But what I find interesting is actually not the tokens so much as the next thing, which is to say the patches that come in with Sora. And of course we don't have Sora released as yet, but we've seen glimpses of something truly astonishing, and we've seen certain capabilities emerging out of Sora. So patches are from videos patches are to videos as tokens are to words. But it's the same principle. But what is astonishing, yes, I think, about Sora is that it's beginning to do certain things. I mean, where they've noticed things like occlusion, where something goes off the scene, it comes back again, and you can still see a consistency in it. It's remarkable. But it has a potential, it seems, to be moving towards three-dimensionality, which is really, to my mind, the truly astonishing thing that seems to be coming out of it. But what is interesting about these all these terms is that we can't grasp them. I mean, there are many things that we can't grasp. We don't know what's going on in the neural network. We don't know what's going on in the brain. But we don't know emergence, either the term emergence itself, or indeed these weird things that they're learning. We cannot grasp it. And I think it's so beyond us in some ways. And it's pointing also to the limit of the human, of the anthropomorphic view of the world, because we reach a certain point where we just simply don't understand it. And it shows us up for what we are. I mean, there was a comment recently by Mo Gaudet who was saying that very soon you're going to find that AI has got an IQ of something like 1,600. If you know, Einstein is whatever he is, and now it's going to go way beyond us. The problem there is it's going to be operating at a level we simply can't understand. And that, of course, we got a glimpse of that from the famous AlphaGo moment when Mu 37 and everyone thought, well, what the hell's this? And actually it was a moment of genius, but it was beyond our comprehension. But just one further point, because I think DeepMind in London is kind of is so important in all these things. But it's these moments when things happen, when DeepMind came along and beat Lee Sedol, and it sent a shock throughout the Asian world, the Go playing nations, and it became what they called the Sputnik moment, when everyone woke up and thought, wow, look at this. And of course, we don't play Go, so we missed on that. But I think ChatGPT was a second Sputnik moment when people thought, my goodness, we know what it's beginning to get a glimpse of what it can do. And likewise, I think with Midjourney, some architects are beginning to get a sense of what it can do. But I think we really need to dig deeper rather than just taking the surface level of things and try and understand the operations that are going on, as you were kind of going through kind of systematically, to understand what's happening. And I think we're getting a paradigm shift where even though we're talking about a complete different world, it's beginning to tell us about our world, and indeed the limitations of our world. So I think this work is terrific, Philippe. I think it's really super important, and it kind of points towards the need for I don't know if you call it theory, but some kind of speculation that goes hand in hand with this kind of acquiring of this data, this information, and so on. So we got to get our head around it. All I would say is that I suspect that also we need to include within that framework the whole world of neuroscience, which is so closely related to AI. I mean, the fact that Demis Hassabis did his PhD in neuroscience, the fact that Geoffrey Hinton has a background in neuroscience before going into AI, and the fact that Anil Seth did a PhD in AI before doing neuroscience. I think this world is really super important, and there is an incredible debate emerging, which I think is something from a theoretical perspective we need to engage with, and stop reading some of the stuff in the past, which, you know, that the same thing is, if you go onto Amazon and go and have a look and see what is popular, you will get Vitruvius and Christopher Alexander as the top selling books. You know, let's hope that your book comes out soon and that'll be the top selling book. But we need to, I think it's more than anything else, I think that AI has confronted us with the problem or the challenges of what it is to be humans and our very limitations. And I think that it can open up a huge new chapter. So Philippe, you mentioned so much there, so much. Please go ahead.
Yes, actually, you know, we have some people who say, oh, humans, what is the specificity of human intelligence is that we don't need to learn a lot. We can identify instantly certain things. And at the same time, we know that for specific kind of knowledge, I mean, either it is mathematics, physics, architecture, literature, whatever, we need to learn a lot. So when we speak about education, in a sense, we are always in between. We are in between the affirmation saying that humans, because they are humans, they don't need to learn a lot, and the affirmation that any expert knowledge needs a lot of learning, basically. So I'm just trying to ask myself, I mean, what does it mean? I mean, is it really true that we don't need to learn a lot to do such a simple thing? And is it really different from spending 5 years in a master program in architecture? And you know what? In fact, my conclusion is that it's not easier to identify a cat. I mean, the babies, they learn a lot before being capable of identifying a cat. Because first of all, before 2 years old, they cannot even say what is a cat. They don't even speak in many cases. And they don't even, they hardly have the concept of what is an animal. So they could say it's a cat, but it does not mean they understand what is a cat, because if they don't understand that it's an animal, it's meaningless, you know, to say it's a cat. So basically, my feeling is that ultimately, thanks to biological evolution, we have a lot of knowledge which is already embedded into our brain. So the brain has been pre-trained by evolution. It's pre-trained in the during 9 months in the body of the mother, and then it's trained massively, but absolutely massively, with millions of new neurons that are created every day during many years. So basically, I believe that everything we need to do requires a lot of learning. It's true for identifying a cat. It's true for becoming a good architect. It's true for becoming a physicist. And because today we are competing with machines that can learn, because for the most part of the human history, the only person who were capable of learning were animals and humans. you know. And now we are suddenly competing with machines that can also learn. So basically, now we need to ask the question of what is learning, how much we need to learn, what kind of knowledge we need to learn. We need to ask this question in a very real way, because all of this has to be addressed against these machines that are suddenly capable of learning in a very interesting way. So architectural education, traditionally, it's about education. I mean, the word is not learning, it's education. It's architectural education. We should invent a new word, a new sentence, and we should not say architectural education, we should say architectural learning. Because ultimately, it's not about educating students, it's about theorizing what kind of learning the student need to develop to compete, not with the teachers, who cares, but to compete with a computer. So the future of architectural education is not about education by the teachers to the students, it's by the students confronted to the computer. So I mean, for me, it's clear that the future of architectural education is not about education anymore. It is the future of architectural learning. And because of that, we need a theory of learning. And this theory of learning in computer science, it exists. In human psychology, it also exists. But now we need to make a junction between the human theory of learning and the machine theory of learning. And I think here we will open completely unexpected paths.
No, I totally agree with you. I just, one thing that I've been reading about a lot recently is I'm particularly interested in the work of Geoffrey Hinton, because he has this double background, both in the kind of, let's say, neuroscience world and AI. And I think that a lot of people in the past have got rather simplistic views about, let's say, the singularity or something, the kind of, as though it was so simple. And what Geoffrey Hinton's doing is breaking it down into different cognitive skills and understanding there are different things that we do. There's learning, which leads to knowledge, but then you've got to move on to understanding how do you use that knowledge, and then thinking is another more advanced form, and then eventually you get to some kind of consciousness. But what was interesting about his comments is that, you know, in learning, he noticed that the kind of computers share their information automatically with 1,000 other computers. In other words, it's a viral form of learning, and we can never compete with that, even though they're much more basic in terms of the neuronal links. Actually, the speed of learning is something astonishing. And the other thing is, because you mentioned the word understanding, and I think the point is that contrary to what Chomsky's saying, I think that these, well, let me say that the work of Blaise Agouiriakos and a few others is saying that actually they do understand. They do understand because they understand in a context. All the data is embedded within a context. They can see those associations, and there is a basic form of understanding that is already there. And this is something that also I think that Geoffrey Hinton's saying, because when ChatGPT answers a question, it's not just predictive text. It's actually understanding the totality of the question and answering it on the basis of that. So all of this is kind of opening up a very new domain, interrogating things that will take us into some new area. I think we have a lot to learn from computation. There's no question about that. This has been, Philippe, this is a conversation that could go on forever. It's such a fascinating piece, and let's keep it going in some ways. I think that unless we got a question from other panelists, I would like to just play out the session with the contribution from Ila, which has been pre-recorded because she can't be with us. But Ila, as you probably know, is one of the not only a leader in terms of the world of AI, but also from working with Ross Lovegrove, is right at the center of debates going on in the world of design, and positioned as they now are in the context of Dubai, which is a city that is pushing forward the AI revolution in interesting ways. They've just formed this new design practice called Deond, D-E-O-N-D, and we can expect some amazing things to come out. So let me share my screen, and this is Ila sharing her thoughts. So Ila.
Hi, Neil. Thanks so much for allowing me to participate to this session. Always a pleasure to contribute to digital futures and exchange ideas and thoughts on any given topic. This one being very meaningful to us all and very important as an education, specifically for architecture and design in the times of AI. So I wrote my notes and I'm gonna dive in straight away. Obviously, it's a subject that we touched together with Ross as well when you were here in Dubai and we recorded our podcast episode. There's no given solution on how educational institutions should adapt and change.
Oh, Neil, we lost the sound of the video, I think.
One
Okay.
is able
Yes,
to
Neil, right. Okay, it's came back. Okay.
and visual design in terms of concepts. Therefore, the definition of design and architecture should shift to more holistic, systemic approach in terms of how you build things, and therefore how we shift from educating at an academic level how to achieve a building. Maybe we should skip straight to how we build architectures at a university level as well, and therefore embrace more performance and purpose-driven kind of educational curriculums. Obviously, all architecture university settings, they have their own labs, but some they lack funding, or they're not progressive enough, they're not large enough, because of course it's kind of separate or subordinate. And how should we shift that upside down? I'm a big fan of ETH Zurich, for example, and how they're experimenting, researching and pushing 3D printing for architecture. And they're one of the ones that are like embracing manufacturing as such, with automation in a big way. So I think this should be horizontally and across all sorts of design and architecture educational settings, and therefore how to introduce more focused education on a problem-solving level that is context sensitive as well, and then keeps all the kind of social environmental aspects very imperative since day one, basically, of how you educate students. And another note I had, what is the value of architecture when we create spaces that not only enhance human experience, but rather take in consideration the big issues of circular economy and sustainability in the planet. I think there are obviously lots of ups and downs, and a lot of downs at the moment, of how AI is just making everything so easy, potentially, and creating this kind of like passive neuropassivity in students and laziness. But it's also a big chance on the pros to really start looking at the subjects that we kind of been neglecting for a lot of time, and nobody took on with a lot of passion, the same passion and determination that we've been taking on other aspects of architectures. I just read recently on LinkedIn that let me just check it. I think it's someone from UN, or maybe not, but the headline in relation to the current climate situation is that we've been given, UN climate chief says 2 years to save the planet as the data, the current climate data tells us. So that's really not good at all. And when you talk about technology and particularly the creative field, and then the computer science field, sustainability always comes at last in the things that we should consider. And of course, AI ethics, it's hugely important because of how fast the technology is developing, but we shouldn't really forget about the planet. And I think this is our chance to actually reverse everything and have it as number one of all of the things that we look at. And then architects must develop a strong sense of critical thinking. So we also talked about this, Neil, during the podcast. How do you educate curatorial skills, and how do you create, how to educate students to refine their eye, not only to aesthetics, but also to what is overall a good or good enough or outstanding architecture, not only based on its aesthetics, but also holistically how it takes consideration to the context, the material source, the manufacturing, engineering aspects, and so on and so forth. And then adapting architecture education to more automation, where I touched upon this. And then obviously experimenting with AI tools since very early on, not to be scared of the AI tools, but embrace them while still keeping in mind that it does incentivize neural passivity, and therefore how to reverse it out to promote more activity at our curatorial critical thinking, lateral thinking. So one of the things that we're doing, for example, because we're seeing it in the workplace a lot, I mean, these days, I don't want to exaggerate, but like 5 out of 10 emails that you receive are, if not more, are completely entirely written by AI, and you can spot instantly when it sounds when it's been written or co-written by ChatGPT, because the lexicon is very repetitive, is very monotonous, and there is just not enough personal touch. So anything that you write or co-write with AI, to just keep on editing and re-editing, and then create this educating in critical thinking and being able to just build upon the AI instead of just laying back and accepting it as it comes forward. And I think that should be done across, even with spatial computing and simulation, accepting the data, although the data, of course, it can be mostly factual. I just think it shouldn't be an attitude that we should have or teach. And then how can universities start to serve as platforms for mentorship, professional growth, and networking, almost at an incubator and accelerator level? Totally into this. And of course, this is how, for example, we're also setting up our own new business here. But this kind of mentality that age shouldn't be a preconception of how we look at students and their level of capability of assimilating not only skill set, but also training and growth at a cognitive and more skill set kind of basis. We should promote startup entrepreneurial mentality. We should promote research. We should fund research. And of course, those are things that, again, some universities already do, but it's usually marginal to the main curriculum and subordinate, or it's like an add-on or an extra hour, is like workshop and internships during the summer. I think the whole layout of a calendar year should be just restructured accordingly. I think we should be doing more of those things that are subordinate at the moment and just reduce the other, because AI and automation is here to stay, and it's just too fast to neglect it, and it's just too fast to not consider how time and space work in relationship to educational years. I mean, architecture in Italy is 5+2. I guess it's the same in other systems. That's a huge amount of time for a young individual to think, oh, I'm going to just allocate this time of my life. It's just non-relating to how the technology is actually developing, where you have 2 years and the entire ecosystem is completely different. So time and space for me are hugely impactful on how we look at education. I think Elon Musk has now taken his prediction of AI, general intelligence, AGI, reaching and surpassing human intelligence. 2029 was his kind of like timeline, and is now bringing it way forward to 2025. That is obviously scary. And if you're a student just about to join education at that level, that's really, really concerning, because if you decide to allocate 7 years of your life and you know that time just in about 2 years or under 2 years, the entire world might be upside down. That's not looking very good, and it's not certainly encouraging, which is something that we don't want to lose. We don't want to lose the hope and the optimism of humans being able to thrive in this age of technological advancement. In the same way we look at optimism for the climate situation, if we lose hope, everything falls apart, because we just don't feel any need for contribution or participation, and we just feel redundant, which is not what we want, especially in young minds and young individuals. And then emphasizing the need for lifelong learning and adaptability. So how do we just re-look at the lexicon and re-look at how we look at ourselves and our career path, and separating, academic, institutional kind of education versus professional and workshops and training and upgrades or whatever. I think the entire ecosystem should just unite. The same way I mentioned the incubator and accelerator, I think there's no kind of like educational before and then education after. I think it's just one continuous journey. And it's just the way it's going to be. We're all going to have to reinvent ourselves over and over, and keep relearning and undoing and unpacking and repacking over and over, because it's the only way we can keep up with the technology. And it shouldn't be, as I said, scary, although it is, because we're not built to be outside of our comfort zone. It's just the way the future is looking. And I think the earlier we embrace this kind of approach, the better for us all. And that's it for me. Thank you.
There was something hugely interesting in what Ila was saying there. I was just picking up on, linking it to what Philippe was saying. I mean, she was kind of arguing for lifelong learning. It does strike me that really this is something that has also been a provocation by the world of AI. The idea that we'd go to university when we're in, I don't know, when we graduate to the age of whatever it is, 23 or some 21, 22, 5 years of education, and then we're equipped for life. It seems to me that is precisely what AI is challenging. We have to continually evolve, adapt, learn, because the world itself is speeding up. And it seems to me, therefore, that maybe we need to think about a model of education that is not just limited to this kind of boot camp, as it were, that we get when we're younger and we carry that with us, but rather some system whereby we're continually updating and refining and learning in the broadest way possible for a world that is speeding up. That seems to be the message that's coming across from Ila. We need to wrap up. I just wondered whether any final comments from the panel here. We need to wrap up just because it's come to the end, but we can continue this, I think, for another session or two. It's almost like we've opened up a Pandora's box of different issues that need to be addressed. And thank you to all our panelists for some incredible talks. Any final comments?
No, just thanks. I think it's definitely interesting to share thoughts about this topic because you know I mean when I first saw the advent of Midjourney, I told my students it's probably the most important year in the history of architecture after the invention of concrete. In any case, it's a moment whose importance is equal to the invention of concrete or steel profiles or the steam engine. We cannot underestimate the importance of that for the discipline of architecture. It's not just about design. It's not just about new shapes or whatever. This is fine, but ultimately it's not important. It's about a complete upside down reversal, let's say, of the discipline of architecture. And yeah, we just need to embrace that in architectural education. There's no choice.
As you're talking, Philippe, I was thinking about what Rem says about the elevator, the lift, how that led to the skyscraper. It completely transformed architecture as a kind of tool that opened up possibilities. No, I completely agree with you. Go on, go ahead, Joseph. Yeah.
Maybe I'll just make one other comment too. A lot of times when I reflect on the moment we're in right now, I also think about the 1960s. And, like Cedric Price says, technology is the answer. What was the question in 1966? But that was the same time period that, like in 1964, in Boston, there was the conference questioning how is the computer going to change the practice of architecture, with both architects like Walter Gropius and Christopher Alexander, but then also individuals like the Boeing Company or at MIT, the Lincoln Lab. And when you look at that conference, some of them, like the MIT Lincoln Lab, they developed Sketchpad, which essentially tried to emulate what we do by hand, but automate it digitally. So it's still a tool. It's still a tool. In that case, it's a tool as a device to augment an individual's ability to perform a task. So it's not a fundamentally different way about thinking. Whether I draw by hand or draw on a tablet, it's still the same way of thinking. But then the Boeing Company created these rule-based geometries where they were essentially creating algorithms to create these three-dimensional geometries. And that was a drastically different way about approaching that problem that we could never have imagined without the computer. And so there, it wasn't just a tool, but it was an instrument to think with. So I think, with AI, there's going to be both. There's going to be some that just automate, but there'll be some that completely transform the framework of how we approach problem solving or problem framing or opportunities. But then I also want to mention that also around that same time period is the year that Friato established the Institute for Lightweight Structures. And there he's looking at things like soap bubbles as a way to kind of simulate tensile inflatable structures. And, if you were to go back to like the Cedric Price quote, is that technology? No, it's not technology, but it's still a very significant intellectual contribution to the discourse of architecture and really an innovative way of thinking about models as forms of simulation. So I think the future of architecture, we have to kind of realize there's going to be parallel trajectories and it's going to be polyvalent and multidimensional. But I'm really excited. And I would say, again, as our school, we're very much just embracing the unknown and not being afraid to keep iterating along that way.
No, absolutely. I was thinking when you're talking about an essay that Ben Bratton put in the book Digital Cities, and all the architects were talking about what the form of the future would be like. And Ben Bratton just talked about the iPhone City. And that device, he said, has changed our understanding, the way we navigate a city more than any architect. I think we're on the threshold of something very special. Behnaz, would you like to make a final comment before we wrap up?
I don't have much to add, but I just want to say that I think I really enjoyed this session. I think also just the use of AI as creatives and either designers, architects in creative fields, we can also shape the conversation around where we want these technologies to go. So I think while the question of ethics and bias has become very, very crucial in this context, I think how we're going to use it, in what context we're going to use it, and how we are sort of shaping conversation around it has become really important as a community. So I'm very excited about this conversation and the possibilities that we could open up as a community to the world of AI and design. So thank you.
Michael, thank you for being here with us today. Do you want to add something because you've been with us the whole time?
Well, thank you all. This was a fantastic session, super interesting, and I think for all of us who are teaching, it is so critical. I mean, for me, I'm an artist, so I mean, I think the differences are marginal here. I teach art classes, and one thing I find myself seeing over and over again is that as much as on the undergraduate, as much as graduate level, students come in with very different backgrounds, very different sort of inclinations to engage or actually with computer science and computational thinking. So, and we discussed this in faculty meetings, to which extent this should there be a separate course, expanding on these things. It's very hard, I find, to integrate this in a, let's say, a 2-year MA or a 1-year MA program, for example. So as much as I think as Joseph was saying, this is an ethical, I think, obligation that we have, because it permeates the classroom, it permeates the studios, but I find the logistics of its integration can actually be still quite challenging, I find.
For sure, we are facing challenges, but I think it's important to recognize those challenges first of all, in order to try and address them. Thank you, everyone. Thank you for the contributions. Thank you also, Michal, for being with us, and thank you also to the Digital Futures team who put together the poster. There is a whole bunch of people behind this, and they're all selflessly devoting themselves to this in the interest of sharing knowledge worldwide. And so thank you for also giving us your time, the panelists. It's been a very provocative question. I think we will come back to it again and again. I think it's a question that needs to be continually interrogated, because the world itself is evolving. I certainly found this an incredibly fascinating session. So thank you all for being here, and until the next time. So thanks so much. Thanks, guys.
Thank you all. Bye-bye. Bye.